Illustrative hypothetical, not a reported incident or benchmark. A fictional accounts payable agent handles only familiar invoice formats from approved vendors. Its signed release baseline says manual entry invoices normally make up 5% of a comparable operating window. In a synthetic live window, the same known slice rises to 45%, 4,500 of 10,000 invoices. The schema still passes, the vendors are known, and the model version has not changed. The monitor should alert. But that alert does not prove that any invoice is wrong, that the agent caused harm, or why the mix changed. Every organization, event, and number in this walkthrough is invented. Distribution Shift Integrity asks whether the live population still matches an approved, versioned reference closely enough for the agent's current authority. It is deliberately narrower than several adjacent controls. OOD Detection asks whether an individual input lacks support under a declared domain. Every invoice here can remain individually in scope. Calibration asks whether confidence scores match labeled outcome frequencies. An unlabeled shift alarm cannot answer that. Sampling Integrity asks whether evidence selected for evaluation represents the target conditions. Behavior Drift asks whether inputs, outputs, actions, or outcomes of the operating system change over time. Distribution Shift can precede Behavior Drift, but the two alerts are not interchangeable. Name the change before selecting a test. Covariate Shift changes the input distribution. Label Shift changes class prevalence while assuming the class conditional input distribution remains stable. Conditional or concept change alters the relationship between inputs and targets. The full joint distribution can also move. These categories overlap in real systems, and unlabeled production data rarely identifies the mechanism by itself. A familiar slice growing from 5 to 45% is observable composition change. It is not automatically label shift, concept drift, or degradation. Write the monitored claim in plain language: which population, which variables, which slice, which reference, which time window, and which downstream action are being protected. Now pin the primary reference. Store an immutable baseline version with cohort rules, inclusion and exclusion logic, feature definitions, pre-processing, time zone, window length, counts, missingness, and known slices. Bind it to the model, prompt, tools, policy, and routing versions that were approved together. Record label availability and lag, because a baseline with immature outcomes cannot support performance claims. Use several representative windows when the operation varies naturally. One convenient batch is not a population. The frozen release baseline remains an audit anchor. If it becomes obsolete, that is a governed change to investigate and approve, not permission for the live stream to overwrite its own comparison history. Add a seasonally matched comparator beside the frozen baseline. Match weekday, hour, billing cycle, holiday status, campaign phase, geography, and other conditions that materially change the mix. In the synthetic example, compare the current Tuesday close window with approved Tuesday close windows, not with a quiet monthly average or simply the previous hour. Keep both views. A change against the fixed release baseline may reveal long-run evolution. A change against the seasonal comparator may reveal an unusual event now. Record exact windows, clocks, filters, sample sizes, and data latency. Report counts and effect sizes with statistical evidence, rather than turning one p-value into a business verdict. Validate the pipeline before interpreting the population. Production data systems can continue through malformed records, silent defaults, changed joins, missing values, duplicate events, and training serving skew. The data validation design described by Breck and colleagues uses batch statistics, schemas, targeted anomalies, and manually curated schema evolution. Apply that discipline here. Confirm source identity, row and entity counts, timestamps, units, category domains, null patterns, deduplication, feature transforms, and routing logic. The 45% share could reflect a real business event, a portal outage, a backfill, or one default value replacing missing channels. If the pipeline is broken, repair and replay it. Do not legitimize the defect by refreshing the baseline. Use a test portfolio, because marginal checks see only marginal changes. Start with predeclared univariate tests and rate monitors for interpretable features. Then test joint structure with a suitable multivariate two-sample method, learned representation, or domain classifier on held-out windows. Two features can preserve their separate histograms while their pairing changes completely. A global test can also pass while a small, critical slice moves in a dangerous direction, so monitor named slices and meaningful intersections with sufficient counts. Answer, Gunneman, and Lipton empirically compare two sample approaches after dimensionality reduction. Their results motivate testing choices, not a universal certificate. Predeclare thresholds, repeated testing treatment, minimum sample size, power checks, and escalation rules. Label shift tools require their own contract. Lipton, Wang, and Smala estimate a changed target label distribution from black box predictions under the assumption that the class conditional input distribution stays fixed, with an invertible confusion matrix. Their method can use an inaccurate or uncalibrated predictor under those conditions, but that does not erase the conditions. A known input slice growing is not evidence that label shift holds. If the team uses a label shift estimator, version the confusion matrix and label definition, test estimator stability, report uncertainty, and look for violations of the assumed invariance. Do not use one convenient shift model to explain every covariate, conditional, joint, or pipeline change. Treat shift_alert as an evidence state, not a diagnosis. The alert record should name the baseline and comparator versions, test and threshold, observed direction, sample count, effect size, affected slices, representative examples, pipeline checks, and downstream authority at risk. Rejecting equality under a chosen test means the observed samples are inconsistent with the reference under that test. It does not prove harm, identify root cause, establish that a particular decision is wrong, or tell the team to retrain. Conversely, failure to reject is not proof of stability when the window is small, the test has weak power, or the monitored projection hides the relevant joint or slice change. Investigation and containment run together. Check ingestion releases, schema and feature changes, joins, clocks, vendor and channel health, campaigns, policy changes, seasonality, duplicate traffic, feedback loops, and representative records from both windows. Preserve evidence before transforming it. For high-impact actions, cap automatic payment value or volume for the affected slice and route excess cases to qualified human review while the facts mature. Leave unrelated authority intact only when separation is demonstrated. Verify reviewer capacity, queue age, service limits, escalation, and audit capture. Human review is a control with failure modes, not a magic label. If capacity is exhausted, suspend the affected automation rather than hiding risk in a backlog. Labels convert a distribution alarm into performance evidence. Obtain independently verified outcomes from the current window and a matched reference sample, allowing for label delay and correction. Sample enough cases inside the expanded slice and its important intersections, a large aggregate set can still starve the group that changed. Replay the frozen system and any candidate remediation. Measure task error, costly false actions, policy violations, calibration, abstention, review burden, and outcome quality by slice, not only in aggregate. Rerun data and shift checks after every proposed transform. Restore authority in stages only when labeled revalidation meets predeclared acceptance criteria and monitoring shows that the containment can be removed safely. Finally, baseline refresh requires explicit owner approval. Package the old and candidate manifests, reason for change, seasonal evidence, labeled results, detector behavior, threshold changes, residual risks, effective time, expiry, and rollback plan. A named risk or product owner may approve the new reference, reject it, or keep the cap while more evidence arrives. NIST AIRMF organizes continuous risk work across govern, map, measure, and manage. Our exact windows, alert states, caps, and approval gate are a practical control design synthesis, not terminology mandated by NIST or the papers. Pin the reference, match the season, test marginals, joints, and slices, investigate before diagnosis, cap authority, collect labels, revalidate, and never let an alert silently rewrite the baseline it is supposed to protect.